Okay, today we're looking at working with piecewise functions. Piecewise functions are literally functions that over one part of their domain they follow maybe one curve, and over a separate part of the domain they follow a different curve. So it could be you have a half of a parabola and then it changes to a line. And in this particular example for f of x, it follows this quadratic from f of x equals 3x squared minus 4x, everything greater than or equal to 2. But everything before 2, it follows this crazy function right here. So when it says to determine the value of f of 3 and f of negative 2, normally it's f of x. And if we were dealing with a normal function, okay, that was not piecewise, we'd simply go and find function f, we'd replace the x with 3, and we'd be done. This one we have two separate functions defined for certain values. So we have to consider, when x is 3, which part of this domain does it fit? So this area right in here indicates the domain restrictions. So since 3 falls into this category, we're going to evaluate the function with this. Since negative 2 falls into this category, we're going to use negative 2 into that function. Okay, so when I ask for f of 3, I'm simply going to go up to the appropriate function where x is greater than or equal to 2. I'm going to take the original function 3x squared minus 4x, and I'm going to replace the x with the 3 as indicated. And if I do that, I'd have 3 times 9 minus 12 would be 27 minus 12, or 15. So very simply, f of 3 equals 15. Remember that saying, when x is 3, y is 15. Okay, the same idea is going to apply for f of negative 2. Since x is negative 2, it fits into this category, so we use this function. So let's see if I can change the size of this. When I find f of 2, I'm going to have f negative 2 equals 3 times negative 2 minus 1 all over negative 2 cubed, the absolute value of that. So I would find that's in the numerator, negative 6 minus 1 is negative 7, and the denominator, I have a negative 8 inside. The absolute value of negative 8 is positive 8, so that's negative 7 over positive 8. So f of negative 2 equals negative 7/8. So when x is negative 2, y is negative 7/2. Negative 7/8, excuse me. Okay, the last part of this asks about the domain of the function. Remember, domain is limits on x. So this section covers everything greater than or equal to 2. So if I put that on a number line, everything greater than or equal to 2 would be over here. This section says x is less than 2. Well, less than 2 would be here. So we have all of these numbers included, 2 is included, and then all of these. So our domain is everything from negative infinity to infinity. There's not a single x value I can't fill in. And that's it for evaluating piecewise functions and finding their domain.